talking about what a parallelogram was, and the next day we kind of proved it's a parallelogram. Okay. Then we talked about what the height, the rectangle, and the square were. So today we're going to work backwards and talk about what it takes to prove that it is a height, rectangle, or a square. A rhombus, rectangle, rhomba is plural. Rhombus. Okay. Anyway, so let's look at this example here. It says information about diagonals can help us classify the parallelogram. In parallelogram ABCD, AC is perpendicular to BD. What else can you conclude about the parallelogram? So we know it's a parallelogram, which means it holds all the properties of the parallelogram. We know that the diagonals are perpendicular to each other. And so, what else could we say about this parallelogram? Yes. Okay, so we end up with 4 right angles there. Okay, good. Okay, so we got 4 right angles right there. Okay, your opposite sides are congruent. True. What about the diagonals that we want to say? Okay, they bisect each other. Okay, so that means that these two are congruent, these two are congruent. Okay, so if I did that, then if I looked at this triangle right here and this triangle here, what can I say about them? They're congruent to each other, right? Okay, why? Okay, you could do SAS. No, you could do SSS. SAS, right? You could do SAS. No, because you said a while ago that your opposite sides are congruent, but I don't know that they're all 4 congruent to each other. You see what I'm saying? Yeah. If I prove these 2 triangles congruent by SAS, now I can say that, these 2 sides are congruent, which in turn means all of the sides, okay, are congruent. Does that make sense? Okay? All right? And so, if all of the sides are congruent, what does it make that parallelogram? A rhombus, right? Okay? Because if all 4 sides are equal, that means that it's a rhombus, correct? Okay? So, that leads us to this theorem. If the diagonals of the parallelogram are perpendicular, then the parallelogram is a rhombus. Okay? Now notice how I underlined this parallelogram. It has to be established as a parallelogram, and the diagonals have to be perpendicular. Okay? Why would it have to be established as a parallelogram? Why couldn't it be any quadrilateral? Well, a rhombus is a parallelogram, but why couldn't I just say any quadrilateral with perpendicular diagonals makes a rhombus? You're done. No, rectangles don't have perpendicular diagonals unless it's a square. Not an isosceles trapezoid. How about a kite? Does a kite have perpendicular diagonals? Okay. So they do, yes. So that's why if you're going to use that to prove that it's a rhombus, you have to establish the parallelogram first. Okay. All right. Here's another one. If the diagonal of a parallelogram bisects 2 angles of the parallelogram, then the parallelogram is a rhombus. So again, if you establish it's a parallelogram, and you can show that one pair of opposite angles has been bisected, then you can say that it's a rhombus. Okay? So you can look at perpendicular diagonals or the fact that one pair of opposite angles has been bisected. Okay, there's another one. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Again, it has to be a parallelogram in order to use this to prove that it's a rectangle. Why is that? Yeah. You said it a while ago. Is there another quadrilateral? Your isosceles trapezoid has congruent diagonals too, right? It's not a parallelogram. Okay? So you can't just say randomly if it's a quadrilateral and it has congruent diagonals, it's a rectangle, because it can also be an isosceles trapezoid. Okay? So if you establish this parallelogram and it's got got congruent diagonals, then it's going to be a rectangle. Okay? Which is the question that it's asked right here. If diagonals of any quadrilateral are congruent, is the quadrilateral a rectangle? And the answer is no. It could be an isosceles trapezoid. Isosceles trapezoid. Alright, so let's work a few problems here. If you conclude that the parallelogram is a rhombus, a square, or a rectangle, explain. So it tells us that ABCD is a parallelogram, right? So, what do you know? Okay. Okay. We also know it's a parallelogram, right? So if, we know that these two sides are congruent and it's a parallelogram, so what can I do from that? Then the opposite sides are congruent, right? So all four of them are going to be congruent. Now, does that make a square? Now, what does that make? It's a rhombus, right? Okay. You can also go with the fact that this diagonal and this angle is bisected, because what's true about angles, they're congruent to each other. Okay, so you can go with that also. Okay, here's another one. Parallelogram PQRS. What is this? It's what? It's a square. Okay. Why is it a square? It's okay, good. All right. It makes the diagonals are perpendicular. Okay, which makes it a rhombus, right? Okay. It's a rhombus because the diagonals are perpendicular. It is a rectangle because the diagonals are congruent. So because the diagonals are congruent and they're perpendicular, it is a square. Good. All right, here's another one. Is each parallelogram a rhombus, a square, or a rectangle? Explain. Now, it says it's a parallelogram, so take it into consideration all the... It should be. If it's in your homework, if the answer is none, I think that's an option that you can. I think there's one that's none. At least. I know this is a parallelogram. What else do I know about it? Okay, opposite sides are congruent. Now, we're working with the diagonals. So what do we know about the diagonals of a parallelogram? They bisect each other. They bisect each other. So if this is a 1 dash, this is a 1 dash, this is a 1 dash, this is a 1 dash. So what does that tell me about these two diagonals? They're congruent. Okay, so what kind of quadrilateral or what kind of parallelogram has congruent diagonals? Okay, what about B? Okay, it's a rhombus. Why? Okay, you have one pair of opposite angles that are bisected. One pair of opposite angles that are bisected. Okay, good. Quadrilateral STUV is a rhombus. So we know it's a rhombus. What are the values of X and Y? Well, this is going to be a rhombus. What's the truth? Okay, the opposite angles have to be bisected, right? So those two have to be equal as well as those two, right? Okay. 25 minus y equal to 5y plus 5 and 4x plus 3 equal to 5x minus 10. So I'm going to add y to both sides, that gives me 6y. Subtract 5 from both sides, that gives me 60. Divide both sides by 60, and y is going to be 10. Okay, solve this. Let's subtract 4x from both sides, add 10 to both sides, and x is going to have to be 13. Okay, so if y is 10 and x is 13, then it is what? It is wrong, right? Okay. Alright. In parallelogram ABCD, draw pictures. When you label it, what do you do? How do you label it? Label clockwise or counterclockwise. So ABCD, it says that AC is 3W minus 1, and BD is 2 times upon BW plus 6. What must be true for ABCD to be a rectangle? Yeah, those diagonals have to be equal. So you're going to set 2 times W plus 6 equal to 3W minus 1. So that's 2W plus 12 equals 3W minus 1. So I end up with W equals 13. Okay, so we talked about conditions for the special parallelogram. Okay, in order for a parallelogram to be a rhombus, one of two things has to happen. What? Diagonals have to be perpendicular or bisect a pair of opposite angles. Okay? In order for a parallelogram to be a rectangle, the diagonals have to be congruent. And in order for it to be a square, perpendicular and congruent, or congruent and bisect off one pair of opposite angles, right? Okay? Alright.